Okay guys, here is segment number 4 on naming ionic compounds. What we're going to do in this segment is combine what we talked about for polyatomic ions into working with our normal ionic compounds and build one big ionic compound together. So to do that, let's go back into our notes. We've already talked about what polyatomic ions are. We've also gone through the process of how you name polyatomic ions and did those. So now what we need to do is take some samples and we need to look at these and say, okay, what happens when we have a polyatomic ion that is attached to a cation? So how do we name the entire thing together now? Because we know this is aluminum, we know this is hydroxide, so how do we combine the two together to make it work? Same thing over here. We know that NO3 is nitrate, we know that Mg is magnesium, so how do we put those two things together? And also, we need to talk a little bit about what these parentheses are and how those work in this segment. Okay, so let's get started. And aluminum is bonded to OH. Now, if we need more than one OH to balance out our charges here, we need to identify that and use a subscript to say how many OHs we need. Well, in this case, because aluminum has a 3+ charge, and the hydroxide ion together has a 1- charge. To balance this out from yesterday, we know that we need to have 1 aluminum and 3 hydroxides. If I just do this, does that tell you that I have 1 aluminum and 3 hydroxides? Not really. It tells you I have 1 aluminum, 1 oxygen, and 3 hydrogens. So to get this 3 to represent for both of these together, we have to use parentheses around it. So now this 3 is telling us that everything inside this parentheses, we got a triple. So for our aluminum with our hydroxide, we need to have that 3 there. Same thing with the one next to it, the magnesium nitrate. Magnesium is a 2+ charge, nitrate is a 1- charge. So we need to have 2 nitrates to balance out 1 magnesium. Okay, so that's where those parentheses are coming from, and we use those. Now, when it comes to naming these, the beauty is it's the same rules as ionic compounds. So aluminum, and you have hydroxide. So we call this aluminum hydroxide. We have a magnesium with a nitrate, so we call this magnesium nitrate. So in terms of our naming systems, it really is all the same rules as yesterday. We just need to deal with these bigger ions now. Okay? Writing the formula gets a little bit more challenging because we need to keep track of our charges. So let's do calcium phosphate and lithium carbonate together. So calcium phosphate following our same rules, we write down calcium, which is Ca. It has a charge of 2+. Phosphate we either have memorized or we look up. And we know that phosphate is PO4. What I would suggest doing is whenever you write a polyatomic ion, bracket it in parentheses right away. That way you remember to treat this as a single item. Phosphate, as PO4, has a 3- charge. Well, I have 2 to 3, so my least common multiple here is 6. So I need to have 3 calciums, and I need to have 2 phosphate groups. Okay? So the only correct way to do this is to have the parentheses and put the 2 outside of that. Putting a 2 and an 8 in here is something different. You have to do it this way. And then finally, when we do our final answer, we wouldn't include the charges. So calcium phosphate would be Ca3, parentheses, PO4, closure parentheses 2. Lithium carbonate. Lithium is Li, carbonate is CO3, put the parentheses around it. Lithium's charge is a 1+, carbonate's charge is a 2-. Our least common multiple is 2 here, so I need to have 2 lithiums. Now this one I'm going to rewrite because I didn't put anything outside my parentheses, so those parentheses really are not needed, so we remove them at that point in time to make a cleaner answer. So we would say that this is lithium carbonate. Okay? And I am going to ask you to do that. So put them in parentheses as you work on it, and then when you're done, if you don't put any number outside of them, just take those parentheses away and then write your final answer this way. So don't put parentheses unless you have to on your final answer. So here's our lithium carbonate. So here's a couple more for us to try. Ammonium chlorate and Cu2SO4. Okay. If you want to try these on your own, go ahead and stop the video now. Otherwise, I'm going to move on and show you the answer key for these. Okay, ammonium chlorate. Ammonium is one of our polyatomic ions. It's NH4 with a 1+ charge. Chlorate is another polyatomic ion, ClO3 with a 1- charge. I have a 1-to-1 ratio, so I don't need to put any subscripts on this. So my final answer would be NH4ClO3. Kind of complex looking, right? You have the nitrogen, a hydrogen, a chlorine, and an oxygen. You have all these things together, and the name just comes down to being ammonium chlorate. All it is one polyatomic ion bonded to another. That's all it really is. Now Cu2SO4, if we start to name this, Cu is copper, and we may need a Roman numeral here, so I'm going to put a parenthesis in just in case. SO4 is called sulfate. So we have copper and sulfate. Let's check copper. If you look at copper, copper is a transition metal. It's in that D block on our periodic table. So because it's a transition metal, we do need a Roman numeral here to tell us what its charge is. Now if we look, we had Cu2SO4, which means we have 2 coppers for every 1 sulfate. Well, sulfate's charge is a -2, and we only had 1 of those. So the total positive charge has to be a +2. It took 2 coppers to do that, so each copper has to be a +1. So inside of here, we would call this copper 1 sulfate. Okay. Notice how our rules haven't changed for anything we did yesterday. It's just now we're adding on a little bit more complex ion to the mix. All right, we're going to stop right here today. These examples we'll start with in class tomorrow. Again, please make sure that you write down any questions you have and come to class tomorrow with questions, and then we'll attack these, which are a little bit more challenging than the ones we just did as examples. Thank you.